Okay, here's a nice summary of CD4 T cell differentiation. First of all, you have your naive CD4 T cell, which when given the correct cytokine, can be differentiated into different T helper cells, and the ones that we're going to be focusing on is T helper 1, 2, 17. We're ignoring Tregs today. So when given IL-12 and interferon gamma, you will get T helper 1 cells. T helper 1 cells, when they're fully differentiated, will produce all these cytokines, but the key one, again, is interferon gamma. Interferon gamma will activate CD plus T cells and also activate macrophages or dendritic cells and enhance MHC. T helper 1 cells are aimed at killing intracellular pathogens, so intracellular bacteria, viruses and fungi. That's why I've drawn it inside this cell, but it's not actually inside a T cell, it's just inside a cell in general. Just as a side note, GM-CSF is a growth factor that they all can produce, and it is used to stimulate granulocytes such as macrophages. So T helper 2 cell differentiation, you need IL-4. IL-4 will then, there'll be a mechanism that we'll talk about later, which will then eventually form the T helper 2 fully differentiated cell. T helper 2 cells express all these cytokines, but the main one is IL-4 and IL-13, which produce an IgE mediators, which then enhance the eosinophilic response and mast cell stimulation. T helper 2 cells are important at dealing with extracellular pathogens such as parasites. That's why I've drawn a parasite. That looks more like a pathogen. Okay, whatever. Outside the cell, so I remember. So what happens is, this is just a side note really. Because parasites are so big, the immune system has to make soluble mediators that decorate the parasite, and so they can get chopped up. And finally, T helper 17 cells, you need IL-6 and TGF-beta to form a fully differentiated T helper 17 cell, and this T helper 17 cell can be, I think, characterized by these cytokines. The main ones are interleukin 17A, this is why this helper cell is called 17 in the first place. There are other ones too, and also TNF-alpha plays a key role in the mechanism. T helper 17 cells are both extracellular and intracellular pathogens. Now, as this is the diagram she's talked through during the lecture, I'm going to use this one for T helper 1 cell differentiation. So, first of all, interferon gamma enters the interferon gamma receptor, which of the naive T cell, which then activates STAT1 and then causes the expression of T-bet. T-bet then activates the interferon gamma promoter and hence more interferon gamma back around the loop. If we read the sentence at the top, T-bet is placed upstream of the IL-12 and STAT4, not downstream. So the T-bet basically helps form the IL-12 beta 2, which is now expressed. This beta 1 was already expressed. This new receptor can now take in IL-12. IL-12 can produce STAT4, which again can produce interferon gamma background. Now there is interleukin 18 here as well, but she didn't really talk about that. But it looks quite straightforward. Interleukin 18 entering the receptor, forming more interferon gamma. Now there are so many diagrams in this lecture, but I found this one to be most straightforward. It's showing T helper 1 and T helper 2 differentiation in the same diagram. So as we just spoke through T helper 1, you can look over that. Yeah. But now let's look over T helper 2. So for T helper 2, you've got unique interleukin 4. Interleukin 4 comes into its interleukin 4 receptor. It then activates STAT6. STAT6 then causes the transcription of GATA3. GATA3 then produces more interleukin 4, hence the expression of interleukin 4 on T helper cells. T helper 2 cells, sorry. Just a side note, there is a decrease in interferon gamma interleukin 12 receptor, because if they were around, it would cause this pathway to happen. Okay, I'm just putting this diagram here in case you want to just read over it. It's not very clear. This is quite a nice summary. So we've got the cytokine that is needed to help the needed to enter the cell. Then we've got the transcription factors, and then finally the cytokines that the fully differentiated cells express. Finally, the cytokines the fully differentiated cells express. So now we need to cover T helper 17 cells. She goes on about interleukin 17 quite a bit, so maybe you should go over that in the lecture, but the main science behind it is that interleukin 17 works in synergy with TNF. She didn't really talk through this, but I'm just going to do it really quickly. So we've got our different interleukins, interleukin A and F, or interleukin 17F. They come into their interleukin 17 receptors and then recruit ACT1, TRAF6 and NF-kappa B, which then causes increased mRNA stabilization. But at the same time, for this actually to occur, we need TNF. We need TNF to come into its TNF-R1 and R2 receptor. We also need interleukin 6 and interleukin 8. Then synergistically they actually work to increase mRNA stabilization. She did mention a few times interleukin 17 and interleukin 17 are family members, but she specifically pointed out this here. She pointed out that interleukin 17RE is specifically linked with eosinophils, I think, and therefore it is interleukin 17C is directly connected to the interleukin to eosinophils as well. So basically, all of these are the different receptors, and these are coming in here are the interleukins. And finally, she quickly talked about the drugs that are being developed in this area and how this T helper 17 cell area is a very hot topic. And these are just a few ways in which drugs can inhibit T helper 17 cells.